Well, here we go with a whole section of word problems and even some train problem, which seems to be the one that's always scary to everybody. Well, with systems of two equations, we can solve a lot tougher kinds of problems, and the key is to break it down into the pieces, translate it into algebra, end up now with at least two equations if we have two variables like in this case. But let's read through this one here. Example 1, endangered species. In 2012, there were 92 species of birds in the United States that were considered threatened or endangered. The number considered threatened was 3 less than one-fourth the number considered endangered. So we familiarize ourselves with these steps. Define the variables. They kind of start with the equations, but I would go into this and say, well, and I'd start reading this thing like I'd say the number of threatened, let's call that T, and endangered they call D, and let's start putting the variables in there. T was 3 less than one-fourth D, if we did it that way. So that starts writing equations for me. In fact, that little statement right there writes this equation. T, which is the threatened, equals one-fourth of D and 3 less than that, or minus 3. Now, where did they get this one here, though? Threatened plus endangered equals 92. Well, that goes back to the first statement. There were 92 species of birds in the United States considered threatened or endangered. Well, that little statement there tells me if I add up the threatened and endangered, I'll add up to 92. So now I have two equations. In this case, they're going to carry out or solve the system of equations. They're going to use substitution method. Probably what triggered that strategy is this. It's already solved for T, so I can just go to the other equation and put this one-fourth D minus 3 in for T, and that's what they did right here. Then they solve the equation for D, and they get D equals 76. Well, now I can put 76 in either one of these equations, and I have an equation with just one variable, so I can solve for that. And they find out that T would be 16 in this case. So then we check both of them. We want to check deal, and you can go back to your equations and stuff like this, but it might be a better check, or it definitely is a better check to go back to the originals and see if it says or makes sense with numbers. So to check this, I got 76 and 16. Well, that first line of this word problem says that there are 92. If you add these two numbers together, you'll get 92. Well, if we add 76 and 16 together, yes, we get 92. Now that's not done because it has to fit, this solution has to fit for both situations. So the next check would be to take those numbers for T and D and put them into this other equation and see if it makes it true. And they get that of they end up with this, or 16 again. Okay, so it does check out. So to state the answer, the other thing too, that's you have to do all this work. It's very easy to not answer the question. You coming back to this whole thing is saying, well, they gave us a lot of information. What's the question? It says how many U.S. bird species were considered endangered or threatened in 2012. So we need to give both of those, right? So we would say, and explain our answer. We'd have to say that 76 were considered endangered and 16 were considered threatened. Okay, the next example is mixture problems, or total value and mixture problems. So let's look at this one. Jewelry design in order to make a necklace. Starbright Jewelry Design purchased 80 beads for a total of $39. Now if we stop there, can we do something algebraically with that? Well, if I have 80 beads, there's a cost per bead, and now they might break this down, but it's going to total up to $39. Some of the beads were sterling silver beads, and they tell us, well, the cost of those were 40 cents, and the rest of the gemstone beads were 65 cents. So we're getting a lot of information here. Okay, so they start putting these things in here together, and we translate the steps from example 2, and then we end up with S and G, which is S is representing the silver and G is the gemstone ones. Well, they told us that there's going to be 80 of them together, and then if we took the number of cents, basically what they're doing here, times the number of the item that they're worth right here. So like the silvers are worth 40 cents and the gemstones are worth 65 cents. Well, I don't know how many there are of each, so that's why they're still variables, but to get the price of the silver ones, you'd take whatever number of silver ones times 40 cents. So they end up with these two equations. Now they're going to use the elimination method here to do that, and with these two in here, they said, well, why don't we take this one and take a negative 40 times both sides. Now that's not the only way to do it, but why did they do that? That's what we need to think. Well, it's just not some memorized step, is it? The strategy here is that they have set this up by multiplying, using the property of multiplication on this equation, is they made these go to 0. When I put these together, add them, or use elimination method, when I do this, the S variable will go to 0, and 0 times S is 0. So now I have an equation with one variable. So I find out that the gemstone one equals 28. That's the number. Well, now I can go back in, and I would go back into the easier one and put 28 in for G and solve the equation. So we have a situation now where the gemstone ones are 28 and the silver ones are 52. We can represent that with an ordered pair, or probably better in this case, because I don't know why you'd decide to put the gemstone ones to the left, or part of your domain, and these part of your range. So it would be better to define the variables, or tell you what the variables are equal to. In this case, G is equal to 28 and S is equal to 52. If you check these, you put those values back in, and you get the first equation right, which is it adds up to 80, and that's true. And if I put this in for the other equation, they kind of broke it out here. The 65G would be 65 times 28 gemstone beads and 40 times 52 silver beads. Well, I get a price for each one of those, and if I add those together, that's my total price of 3,900, cents, or $39. So the number's checked, okay? And putting the equations together and then solving that system. I think I'm going to skip this one. We're going to get down to mixtures here a little bit more with some other things too. There's a really nice summary of mixtures that we go through. I kind of want to jump to that. This is a pretty good problem solving tip here. You're going to find out as you do these word problems that there's going to be a real lot of similarity between some of the problems, but be careful. It may not be exactly the same steps, but the key is to get those equations written and those kind of things. So let's look at this one here. Spend a little time here on mixtures, which is usually some of the tougher ones. It says in order to have a 90 mixture of Gentle Grow and Sunsaver with 6% nitrogen, two things must be true. First of all, if you're going to take these two solutions as Gentle Grow and Sunsaver and mix them together, you need to come out with that 90 liters because that's part of the condition, right? Well, the other part of that is I need to take whatever those volumes are, and this one has 3% of nitrogen, and this one has 8% of nitrogen. We need to get whatever amount of liters that we get here, we want that to be a 6% solution. Well, they do tell us 90, so we can pull out some numbers from that. In fact, 96% of 90 is 5.4 liters. So we're going to look at how to set that up into equations that we can work with. And if you look at these things here too, it says for each mixture illustrated below, find the total amount of the mixture. So this mixture right here is what they're talking about. If I have 30 liters and 60 liters, how many liters are going to be in here? That's pretty straightforward, as 90, right? Okay, and then also the total amount of nitrogen. So what I'm going to look at here is saying, well, I know that this is 30. If this is 3% nitrogen solution, so what's 3% of 30? And that'll tell me how much actual nitrogen is in that solution. And the same thing with the 60 liter Sunsaver. I'll take, in this case, the Sunsaver has a different percentage of nitrogen. So I take 8% of 60, and that'll tell me that I got 4.8 liters of nitrogen in this one, and this one I have 9 liters of nitrogen. I'm still, when I add all that stuff together, I'm still going to have that 90 liter mixture. But here's 9 liters and 4.8 liters. So I'm going to have 7.8 liters in this mixture of 90. And that's the next question. They say, well, what's the total amount in there? I know there's 90, total of 90 liters, and then I've just found out that I have 3 plus 4.8 or 7.8 liters of nitrogen in the solution. This one here I got 10 and 80. So, and I end up with how many liters right here? That'll be 100 liters of this solution, the mixture. Well, okay, so I know the total volume again. These need to add up to that. And now we want to say, well, if this Gentle Grow has 3%, so 3% of 10 liters is 0.3 liters, okay? And this 80 liters is not 3%, it's just 8%, so be careful. And then I get 6.4 liters. Well, I know I got how many in here? 90 liters, because that's how much fluid I have. And then I figured out what each one of these was for nitrogen. You'd add that together, and that's what that is. And so on. Well, we could draw pictures, and that's good and stuff, but why not organize our work here? And this is a very good strategy. Let's put what we know into a table, and we can probably get some equations out of that as long as we set this up correctly. So they set up number of liters, percent of nitrogen, amount of nitrogen. Here they got the Gentle Grow and Sunsaver, and then the mixture. Well, here's a number of liters of each one. They go with G and S, and you'd end up with 90, because we know we need to have 90 liters. The percentage of nitrogen and the percentage of nitrogen in each one of these, Gentle Grow and Sunsaver, They don't really tell us much. We know that we need to make that equal to 6%. And I'm looking at that and I'm going like, well, it's a little more complex that I can't add them together. I can't subtract and get 6 and so on. So there's no real equation I'm going to pull out of that. I need to bring in this next part, is that the amount of nitrogen in each of these individual things, and then that'll give us some good information. And now we have two equations with two variables. So they go through, in this case they did elimination again. They multiplied both sides of this equation, this red one, by -3, and this is a resulting equivalent equation. And why they picked -3 was to get this to drop out or match up, so they'll go to 0 term as a constant. So they go through and they solve basically that situation. With the elimination, we get s as one variable solve. You get s is equal to 54. Put it back in one of these equations, and I get g is equal to 36. Now, does that make sense that we would have 54 and 36? What does that add up to? And that adds up to 90. So we're on the right track, okay? And that's what they kind of show us here. Well, the total amount of nitrogen in each one is 3% of the 36. Since I actually have a volume to work with, I can do this calculation. And same here, I can take 8% of 54, and I'm going to end up with actual numbers. Well, the percentage, again, is based on these solutions, which probably should have covered earlier, is the amount of solution that we were looking at, like in this case nitrogen, over the total volume of the mixture. Well, we'd end up with 5.4 liters of nitrogen all in this container of 90 liters. And what would we get if we want to put that into percentage? That means that's hundreds, or do the division, you're going to get 0.06. And that's what all percent means, is 600ths. Okay. So with that, we can figure out how much of each solution I need to have to mix together to get not so much about how much total volume of stuff you have, but the mix at the end. If you want to focus in on getting the right percentage, you're going to end up in a situation similar to this. Well, here they come, the train problems. We got distance and rate and time equations and that kind of stuff. So that's what's coming next, and I think I'm going to just do a video specifically about that, and maybe even review a little bit more about the mixture part, because that's where most students seem to have their problems.